can start the session. Can you people hear me and see the screen?
Yes, yes.
Okay. So in the last class, we were seeing about MP neurons. Okay, and we saw about the OR function, how it was linearly separable, and we also saw about AND function, how it was linearly separable. We saw about tautology, and we saw about how it was linearly separable. Okay, so and we also saw about the three inputs and how it was linearly separable. And we saw about some disadvantages also, and we concluded in MP neurons, linearly separable for Boolean functions, there exists a plane such that all inputs which produces a 1, okay, is on the other side of the plane, and all inputs which produces 0 is on the other side of the plane. Okay, this is what we saw. Okay, so the next one, we will move on to the concept of perceptron. It is the same concept what we have been using in MP neurons, but with some more added advantage. Okay, that is called perceptron. Now, let's see what were the drawbacks of MP neurons. What about non-Boolean, say real inputs? Because in MP neurons, the input was 0 and 1, the output was also 0 and 1, right? That is the Boolean function. What about the values for 2, 3, 4, 5, 6, 7? Okay, so what about the non-Boolean numbers, say real inputs? Okay, always need to hard code the threshold. Are all inputs equal? Okay, because what was the disadvantage in the thing we saw? The thing we gave, all inputs were given equal priority. Okay, all inputs were given equal priority. Okay. Okay, what if you want to assign more weight? Say for example, in MP neuron, we were talking about actor, director, then music, and then we also spoke about thriller. Okay, say for example, if what did we do if all 4 were given equal inputs? But here in Perceptron, if the movie is a thriller, okay, if the movie is a thriller, irrespective of whether it's an actor, director, and a musician, I will watch the movie. So the most important weightage I will be giving it to thriller. Okay, I will be giving it to the movie. I will giving it to the type of movie called as a thriller. Okay, but this here the weights are going to be very less. Okay, the inputs, the weightage I will be giving it very less. Okay, or if the actor is Arnold, irrespective of the director or the music or the movie thriller, I'm going to watch the movie. But in MP neuron, once the threshold is set, it should be A, T, M, and T only then, okay, then I will be able to watch the movie. I will be able to predict that I can watch the movie. But here, okay, if the movie is a thriller, okay, I am really focused on the thriller alone. So the input will be more on thriller. Okay, rather than the actor or the director or the musician, irrespective of whatever it is. Okay, so all the inputs are equal? No. Okay, in Perceptron, we want to assign more weight to some inputs and less weight to some inputs. Okay, I'm least bothered about the music, so I can give low weight to the music and the director. But as far as the movie is a thriller and my actor is Arnold, then I will watch the movie. So the weightage is given more. Inside these two also, I can give more weightage to one or the other attribute. Okay. What about the functions which are not linearly separable? Okay. So Frank Roseblatt, an American psychologist, okay, proposed this classical perceptron in the year 1958. Okay, so what he did is, given an input x1, x2, x3, x4 till xn, okay, you add a weight to it. Okay, he added a weight to the inputs. Okay, he added the weight to the inputs. Okay, and he played with the inputs. But if you look at the MP neuron, can you see? If you look at the basic model of an MP neuron, there is no weights. But in MP perceptron, okay, the only difference is we are adding weights to the inputs. Okay, we are adding weights to the inputs. And if you want to give more weightage to x2 and less weightage to x1 and full weightage to x3 or equal weightage to all four, you can play around the weights. Okay, more general computation model than MP neurons. The main difference is introduction of numerical weights for the inputs and a mechanism for learning these weights. Okay, and the mechanism for learning these weight means what? Okay, how each input will react to a particular weight. Okay, that is for you, actor might be of more weightage. For me, the director might be of more weightage. Okay, for Raj, a thriller movie will be of a more weightage. For Kiran, all four are of equal weightages. So different people might have different tastes, and their weights are changing accordingly. Inputs are no longer limited to Boolean values. Inputs can be 0, 1, 4, 6, 8, whatever it might be. Okay, redefined and carefully analyzed by Minsky and Papert in 1969, and this model is referred to as a perceptron model here. Okay, now what is the equation of the perceptron? A generalized equation of a perceptron. What is a generalized equation of a perceptron, students? X1, X2, X3, X4, right? That is X1 into W1, X2 into W2, plus X3 into W3, plus X4 into W4, plus Xn into Wn or Xi into W1, whatever you call. If it is greater than threshold, it will fire 1. If it is less than threshold, it will fire 0. Okay, you're getting the point, students? Hello, you're getting the point? You're able to understand? Very simple concept. Hello?
Yes, sir.
Yes, sir.
Okay, so now you are aggregating. So that is x1 into w1 plus x2 into w2 plus x3 into w. That is why I have put summation. You see, that is why we have put summation. After summing up, the aggregated, okay, x1 into w1 till xn into wn, if it is greater than or equal to threshold, it will fire 1. If it is less than threshold, it will fire 0. Can this equation be written like this? I am just bringing the theta on the other side. Okay, I'm bringing the theta on the other side. Okay, so minus theta. Now if it is greater than 0, it will fire 1, and if it is less than 0, it will fire 0. Okay, it will fire 0. This equation can be rewritten as, can you see, now I am taking theta and I am adding a constant bias to it. Okay, that will be x0, which is constant, which is always going to be 1, and a bias which can be minus theta. Okay, which can be minus theta. This same thing which I am writing right like this. You see, I am writing like this. Okay, so my concept, okay, why I am writing like this is, why this bias is added, consider x1 is also 0, x2 is also 0, x3 is also 0, x4 is also 0, xn is also 0, then everything is 0, then my summation will be 0 always. Okay, to avoid this, I am adding a constant value, 1, and I am adding a theta value, a weight to it. Okay, and I am adding a weight to it. What is a minus theta? So that is what it is. Okay, then I am rewriting the equation w1 into xi, that is w1 into xi. If it is greater than 0, it will fire 1. It will fire 1. If it is less than 0, it will fire 0. It will fire 0. Is it clear? Is it clear, students?
Yes, sir.
Is it clear? Okay, where a constant, okay, x naught, okay, and w naught equal to minus theta. Some constant I'm adding, okay, with x naught and w naught. Okay, now let's proceed. Now what are you going to try to answer the question? Are we trying to implement the Boolean functions? Why do we need weight? And why w naught is minus theta called the bias? Okay, fine. Consider the task of predicting whether we would like to watch a movie or not. As I told you, students, as I told you, your preference might be different, my preference might be different. Consider, okay, suppose we have a decision on 3 inputs, a binary for simplicity. Based on the past viewing experience, we may give a weight to director Nolan as compared to the inputs. Okay, if my director is Nolan, okay, then I'll give more weightage to it. I'm not bothered about who is my actor, is Damon and a genre is thriller or what. So as far as my director is Nolan, I'll give weight. Okay, specifically even if the actor is not this one and it is not a thriller, if my director is Nolan, I'll give weightage. Okay, so W naught is called the bias as it represents. Okay, any movie. Okay, so consider you are somebody is a movie addict. Irrespective of whoever may be the actor or a thriller or whoever may be the director, okay, he's going to watch. Then what will be my threshold? It is going to be 0. Because definitely he's going to watch, right? He's going to watch irrespective of whatever may be the thing. Okay, but on the other hand, a selective movie, okay, who is going to be very selective in thing. Okay, his actor should be Damon, the movie should be thriller, and the director should be Nolan. Then his threshold becomes 3. Okay, consider Raj is very selective in watching movies. Then his threshold becomes 3. Okay, based on this 3. Okay, so equal weightage is given to all the 3. And the bias depends on the data and it depends on the viewing history also. Okay, so what kind of function can be implemented with the perceptron? Any difference with MP neurons? What is the difference? What is the difference between MP neuron and perceptron? What is the difference, students? What is the difference? What's the difference, students?
The weighted.
Very good, right? Here, summation of xi, right? MP neuron, I equal to 1 to n. Okay, if it is greater than or equal to threshold, it will fire 1. If it is less than threshold, it will fire 0. But what about here? Summation, same formula, I equal to 1 to n, xi into wi, that's all, students. Okay, if it is greater than or equal to threshold, it will fire 1. If it is less than threshold, it will fire 0. Okay, now can we say that both MP neuron and perceptron, there exists a linearity? Is if it is beyond this decision boundary, it is classified as 1. Beyond the decision boundary, it is classified as 0. Okay, for MP neurons, I'm talking about for MP neurons, right? For tautology, something like this happened. Okay, so this is the difference, right? summation of I equal to 1 to 0. If it is greater than 0, it fired 1. Consider the threshold in this case is 0. Okay, and if it is less than 0, it fired 0. What about perceptron? What about perceptron, students? So Wi into Xi. If it is greater than 0, it is firing 1. If it is less than 0, it is firing 0. That's all. Very simple, right? Okay. One more thing, if I can add, we can add an X0 equal to 1 and W0 equal to minus theta. I can add. Yes or no, students? You are able to understand? Everybody is able to understand whatever I am teaching? Hello? Everybody is able to understand whatever I am teaching?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, what about others? What about others?
Yes, sir.
Yes, sir.
So, from the equation, it should be clear that a perceptron separates the input space into two halves, just like MP neuron. Just like MP neuron for OR gate, for AND gate, and for tautology, and for hyperplane, right? I mean for a plane. We saw, right? For a plane. Like higher MP neuron did. Okay, so all inputs which produces 1, okay, lie on the one side of the plane, and all inputs which produces 0 lie on the other side of the plane. In a word, single perceptron can only be used to implement linearly separable functions. What is the difference? The difference is in weights, which can be learnt. Okay, and the inputs can be real valued. We'll first revisit some Boolean functions and see the perceptron learning algorithm. Okay, so just to make sure, okay, I'm adding it, I'm expanding my single layer perceptron. So single layer perceptron is a feed forward network based on the threshold transfer. Okay, a simpler type of ANN, that is artificial neural network, that can classify linearly separable cases with the binary targets. Here also the target is binary only, but input can be binary, okay, that is Boolean or an integer value. Input can be a Boolean or an integer value. Okay, so whenever you are adding summation, okay, the theta, okay, if it is greater than the threshold, it will fire 1. If it is less than the threshold, it will fire 0. Now, single layer perceptron. What am I going to do? I am just representing the same thing in a different variety of way. So x1 w1 plus x2 w2 plus x3 w3 plus x4 w4. Okay, can you do? I'm summing it up. Plus, I am adding a bias. I told you, right? I added a bias, right? I added a bias. Okay, I added a bias. X0 equal to 1 and theta, okay, equal to minus theta. See, we'll have it as a bias normally, as a bias. Okay, we'll add it as a bias. Okay, I am adding as a bias and some error function. When I am adding up, okay, I get some value. Okay, I get some value. That students, I get some value, and that value, my activation function will classify whether it is 1 or 0. The value which I am getting from here is put inside the activation function. If my value is greater than or equal to 0, it will shoot it as 1. It will classify it as 1. If my value is less than 0, it will classify it as 0. Very simple, right? Yes. So I am adding up the weights. Okay. I am adding a bias to it. This bias is a user dependent. Please understand, the bias can be 0 or 1 or 2 or 3, and it can be anything. Okay, it is a user dependent value. Okay, it is bound to change irrespective of how you take up your project. Okay. So now, whatever the value you are getting from these two, okay, is put into an activation function, okay, if this value, say for example, I'm getting 4. If it is 4 is greater than or equal to 0, then my f of x will be 1. Okay, but if I'm getting minus 2, say for example, which is less than 0, then it will classify it as 0. It will classify it as 0. It will classify it as 0. Is this very clear to everybody? Is this very clear to everybody? Hello?
Yes, sir.
How many of you are able to understand? Raise your hands. Raise your hands. Okay, fair enough. Okay, so we'll proceed forward. That is the same steps, these 4 steps, right? 1, 2, 3, 4, and the 5. And the final function is, it is classified as 1 or 0. Okay, it is classified as 1 or 0. Okay. On the left hand side, you have neurons, small circles, which is, I'm carrying data inputs. So these are my inputs. I'm just explaining the same thing. Okay, we multiply this inputs with the weight, which is the weight. Okay, also labeled as 1 to m. Okay, this is called a synapse. I have told you, okay, right, what is synapse? Okay, so w1 into x1 into w2 x2 into w3 and the answer. Once all the inputs are multiplied by a weight, we sum up them and add another predetermined number called as a bias. Okay, this is third part. Okay, once we are summing up, okay, so w1 into x1, w2 into x2, w3 into x3, w4 into x4. This is input, this is input, this is input, this is input, this is weights. I am doing it up. After summing up, I am adding with the predetermined number called as a bias. Okay, so called as a bias. Then we push the result further to the right. Then we push the result further to the right, to the activation function. This is an activation function. To the right, in the rectangle. It means that if the result from the step 3 is an any number equal or larger than 0, we get an output as 1. Otherwise, the result is smaller than 0, we get an output as 0. The output is either 1 or 0. So the activation function will be, output will classify it as 1 or 0. So whatever may be the inputs, so it can be a 2, 4, 6, 8. Okay, this is just to make you understand. Consider all in weights are 1. So 2 plus 1, 2. Okay, 4 plus 1, 4. Plus 6 plus 1, 6. 6 into 1 is 6. Plus 7 into 1 is 7. So 6, 10. 10. Then I am adding a bias as 1. Consider. So 4, 5, 6, 12, 12, 17, 18, 19, 20. So 20. So 20. So 20 greater than or equal to 0? Yes. Okay, 20 greater than or equal to 0? Yes. So what will be my output? 1. But if I get something like this, if I have minus 2, minus 4, okay, 6 and minus 7, then I will get less than 0. Then I will classify it as 0. Are you getting it, students? Are you getting it? Are you able to understand? Are you able to understand, students?
Yes.
Hello? Able to understand? Hello? Okay.
Yes, sir. Yes, sir.
Yes, sir.
So now the same thing, I have written it in different way. That's all. This is the inputs, this is the weights. I am adding the summation with the summation bias. Okay, then I'm putting it into the activation function. My activation function is the y output. Okay, is the output. Okay, this is my actual output. This is my output. Okay, this is my predicted output. Y cap is my predicted output. This is my predicted output. Okay. So W1, W2, if it is greater than threshold, it is 1. If it is less than threshold, it is greater than or equal to threshold. Okay. This is This is wrong. This is greater than or equal to threshold. This is less than threshold. Okay, it will execute 0. That's all. Okay. Now perceptron. Now having said that, it is able to classify 1 or 0. So perceptron is an algorithm for a supervised learning for binary classifier. Okay, it is 1 or 0 means what? Binary classifier, right? Supervised learning is when a model is getting trained on a labeled data set, and the labeled data set is one which have both the inputs and the output parameters. Right? We have been seeing decision tree, yes or no, true or false. Okay, linear regression. Okay, it is able to classify. The same thing, perceptron is also a supervised learning algorithm which is able to classify a binary classifier, whether it is 0 or 1. Okay, so given a data set x1, x2, x3 and the weights, okay, and we don't know the hidden output. Okay, so now we are calculating. So the data set, it can be cat or a dog, right? It can be 1 or 0. Okay, this enables you to distinguish between two linearly separable classes, that is 1 or 0. Okay, your -1 is there, you can have it as 1 or 0. Okay, now what is the perceptron learning rule is? Okay, now students, given x1, x2, xm, okay, weights is given w1, w2, wm, and okay, a constant value and a w0. Okay, now we put it into the function, we calculate the sum and the bias, right? And the activation function is there. Okay, now students, now we are going to have a target value, that is the actual value. Actual value means it's given in the data set, right? It is given in the data set, and you are getting the output, which is a predicted value. Students, I am telling you everything in this slide itself, so kindly please understand, and I am keeping things very simple. Okay, now given a data set, students, you have got say for example pass, okay, pass, fail. Okay, now the output you are getting it as pass. So this is the actual value, this is the predicted value. Now you are comparing these two. If my actual and my predicted is correct, then I will not change the weights. It means that what weight I have assigned to my inputs is correct. But if my actual, say for example, my actual is yes, but my predicted is fail, it means that there is a mismatch, right? There is a mismatch. Because there is a mismatch, okay, I need to go and change the weights, and I need to modify the weights. I will keep modifying the weights till all my inputs, whatever my target value is same as the predicted value. Okay, so I will show you with the help of a problem. Okay, so that is okay. So x1 w1, x2 w2, xn wn. Consider I am putting it into a summation function for this x1 w1, whatever may be the things. Like for example, I have my x1 feature, okay, x2 feature, all these things are my input for Raj, and finally it is predicting this as pass. Okay, now I am putting it into the activation function, and my activation function is also predicting it as pass. So both are pass, so there is no error, right? My actual is also pass, my predicted is also pass. Okay, what is an error, students? We have been studying, right? In a linear regression, we have been studying all these things we have been studying. So the difference in the actual minus predicted is the error. Yes or no, students? The difference in the actual minus predicted is the error. Yes or no? Hello?
Yes, sir.
Yes. Okay, the difference is the actual minus predicted is the error. So here, is there any error? Is there any error? Hello? Is there any error? Hello? Any people understand what I'm asking you? Hello? Hello?
Could you repeat, sir? Like, I don't understand why you are asking the error.
No, pa. Consider, okay, after summing up, okay, I have a data set. Okay, these are my input values. X1, okay, W1, X2, W2, X3, W3, okay, X1, X2, X3 I have given. These are my input values, and my final classifier, I am classifying it as pass. Okay, so these are my input values, 4, 3, 2. Okay, so what am I going to do is 4, 3, 2. Okay, now I am adding it up with my weight. Some weight is there. Okay, just imagine I have set the weight as 1. Okay, whatever may be the thing. Okay, I am not getting inside the concept itself. I am asking you a basic common sense question. Okay, so now what happens is my target value is pass. Now I am getting inside the summation function. My summation function is also predicting pass. This is my y. Okay, this is my y. So now my target in my data set, it is predicting, okay, my data set is classifying it as pass, and my output is also classifying it as pass. Is there any error, I am asking you?
No, sir.
There is no error. If there is no error, this will be my output. That's all. I will not keep any hands. I will not do any further modification. I will just go to second phase. That's all. But now consider, okay, so I am putting my inputs as this one. I am doing some modifications with weight, okay, and my final output is predicting fail. My final output is predicting fail. Okay, what is my classifier predicting? What is my classifier predicting?
Pass.
Pass. Is there any error?
Yes, sir.
Is there any error?
Yes, sir.
Yes, there is an error. So when there is an error, what I will do is I will go ahead and modify my weights. This is what it is telling. Is that clear? Is it clear? Is it clear, students?
Yes, sir.
Hello? Is it clear? How many of you are able to understand? Raise your hands. Yes? Okay, very good. Okay. So, for the modification of the weights, when there is an error, I will go for this formula. I will tell you. Okay, I will teach you. Okay, so I will teach you with the help of an algorithm. Okay, I will teach you with the help of a problem. Okay, for AND gate I will teach you. Okay, so now what is happening is, what's the time now? 10:34. Yeah, if I start, okay, if I start, I will then I will be able to, will not be able to complete. So have you understood this, students? Have you understood this? Have you understood till here?
Yes, sir.
Have you understood till here?
Yes, sir.
Yes, sir.
Okay, so I think so with this I will stop. It's already 43 minutes. Okay, so with this I will stop here.